Okay, that's live. Now you should hear, Will, now you should hear talking. You should hear us.
Especially if we're talking loud.
I can hear you.
Can you hear now?
Okay.
Yeah.
Can you hear me now?
All right, then we're ready to go.
As ready as we'll ever be.
Yeah, pretty much.
Pretty normal for us, right? One of our presenters has to say.
Yeah. Thanks for coming out, everybody. Pat, if you want to go ahead and get us kicked off,
Yeah.
stuff comes up.
So we are technically at the Uhug meeting, right?
Yeah.
I think so. We'll have Lonny come up and present here too about some other technical topics, but we're going to talk about what we've done on the house team for the air quality competition. Upcoming events right now. Tomorrow, I don't even know what it's called exactly. Big data competition, was that what it was called?
It's the Utah data competition.
Utah's
top data scientist.
Data scientist, yes. Ben Taylor tomorrow. That's it'll be at the Jordan Commons movie-plex. They're going to talk about the awards, what they did, and all that sort of things. You can find it on Meetup. Do we have it on Meetup?
We don't have it on Meetup because it's an event, right?
Right.
And so
if you want to go, let us know. It's open to everybody. And then next weekend is Big Mountain Data. Who has not registered for Big Mountain Data?
the Big Mountain Data Conference.
Big Mountain Data Conference. You need to register for the Big Mountain Data Conference. If you're interested in data at all, that's the place to be next Saturday. Okay, we're going to have over 500 people. We've got 57 sessions right now, all day long. A whole Ask the Experts area where you're going to be able to talk and bounce ideas off of people. Basically, anything to do with data, big data, or any other topics around data will all be at that event. So not something to miss. There's a flyer over here if you want one, but definitely register at UtahGeekEvents.com. It's free.
Some of it be recorded?
There is a chance. We are working on broadcasting some of the sessions,
Yeah.
not all of them. So we will work on Google broadcasting a few of the sessions, but not all.
Well, I'll put that another thing that we can.
Yes, yes. So, but yeah, UtahGeekEvents.com is where you go to register. And like I said, if you need a flyer, go ahead and take some of these flyers as well. That's all for the updates. Okay, so now we're going to talk about the air quality competition, what the house team did. Let's start with introducing the house team, and then let's talk about our goals.
Okay. Yeah, so the house team. So first, let's go all the way back to what we wanted to do originally. So Utah is one of the leaders in big data out there, period. And we started realizing that about a year ago, actually around the first Big Mountain Data conferences. We had hundreds of people come out. We started getting people practical experience with different competitions that we put on. We had sentiment analysis and predictive analytics and some very, very cool advanced stuff in the technology sphere. We created this goal to make Utah the big data hub, and since then, we've been driving toward that in as many ways as we can think of. And we'd love help from everybody in the community and everybody in Utah to be able to do that. We obviously can't do it on our own, and neither can any of you, right? So we've had additional conferences and everything, but we also wanted to take on a competition that meant something to all of us, not just something that was very specific to a company, and something that could affect all of our lives and get us a lot of recognition for what we could potentially do. After much prodding from Pat, we decided to take on air quality. Here in Utah, that is a major deal, although as some of the teams have shown, much of our air throughout the year is really good. There are times when our air goes beyond just slightly unhealthy to extremely hazardous health conditions. And it can put us in very bad situations for whatever stage of life we're in, whether we have kids, whether we are a kid, whether we're in the womb. It can put us in situations where we die, where we have cancers, where we have some very, very complicated things happening to our health, right? So the house team, we decided to put on this big air quality competition. I will let you go into all the specifics of it, but we came up with two major goals. One is to help grow this big data community that I just mentioned, And the other one is to make sure that we do something about the air. And I'll touch on some other specifics that we drilled down. So,
House team, so our house team was Pam, go ahead and stand up. Pam was part of our house team, Pam Bradford. Jonathan, stand up. Sue will be presenting tonight too. Craig is not here yet. So we might be missing a presenter, but we'll get Craig in there too. Myself, Nick, our I want to say pseudo house team. I mean, we basically cracked the whip on everybody, but as organizers of it, we're not allowed to win anything. We made sure to talk to everybody, so we wanted to keep that very well known. We had a few other team members too that helped out. They're not here tonight.
Matt Davies just came in.
Matt Davies just came in, yeah, helped out.
So, quite a few others.
Yeah. So what we were looking to do, as Nick mentioned, clean the air in Utah. We wanted to improve the air quality in Utah. That was one of our major goals at the start of the competition. We wanted to grow the big data community. We wanted to make a lot of people learn a lot more things about big data and make us more of a big data hub. And we're still working to that right now. And then make a brighter future for all, make everybody happy, and everybody have unicorns and stuff like that. So it's a perfect harmony. I think we came really close on that one. The other two, we're not sure about, but that one, we're really, really close. So to talk about some of the things we did, my part of this was basically making a summary and kind of showing all the great things we did over the whole summer. So we made this summary up for the state of Utah, and we wanted to share it with everybody else too. For those of you that came to every meeting in the summer, thank you. We had 10 weeks, basically 10 grueling weeks of 30 meetings, really is what it translated out to, about 30 meetings. That's a lot. That's a lot of meetings and a lot of pizza and a lot of Subway. So we had a lot of meetings. We have a lot of great YouTube videos up there. I refer to these all the time. I tell people about the Spark presentations we had and the presentations on air quality and all the different things. These are great. You can send people to these all the time. The data sets we found were over 300 plus data sets. I mean, that's just awesome that we came up with that many in a 10-week period to find out there on the internet. Recorded in Jira, we had about 50. The 300 comes from a whole other branch that Pam did right towards the end, and then sent them in right at the last day, so I didn't have time. Somehow I was busy all summer. So data sets cleaned, collected, already up on the Civic data site is 6. There's more than that now. Brett has turned in his as well. They have not been placed on the big data, the Open Civic site, but they will be in the next few days. So all of those up there, there's a ton of great data. And then we changed to the part of being a big data community. Registered members, we started our meetup, Matt, when was it? May, right? We started the meetup in May.
Right.
Yeah, did we start it with 200 or did we start it with nobody?
We started with
three.
Yeah.
us, and then now it's 300 plus.
Yeah, now it's 300 plus on our meetup now. So we've grown that much just over the summer for the big data community. And that's awesome. That's really, really great. And then there's some other numbers here too. For the newsletter, during the summer, we had 70 active people on the newsletter. And the competition, we had about 72 people total participants in the competition. So again, that's a huge number for participating in these things. And then we had the first big data mixer back in September, just a couple of weeks ago, where we had 50 people attended in that as well. A lot of people here participated in that, got a lot of good information out of that. So, and then of course, we're going to be announcing all the awards at the Big Mountain Data Conference coming up on the 25th. So it's a huge thing that was done over the summer. I want everybody to understand that. And it's not just Nick and I that did this or anything, the whole community did this because you put in the time to clean the data sets, to get them ready, to work on them, all of those things, just an amazing effort all summer long. So now we're gonna have to find out what you gotta do next year to make it even bigger. We'll talk about that in a couple days. So, questions on what we have done? Any comments, anything that anybody wants to add about this summer as well? Oh, probably another one that we want to mention is the noobs. Okay, I call them the noobs, but a lot of people tell me over and over again, we just met the entire team. WinVersion is a great example of this. They mentioned this in their presentation. None of them knew each other, almost no one. They built a team, they put together a solution, they did all of that in that time frame. And I don't, it's part new, we just came together as a team, and that's just awesome. And now there's fast friends, there's future employees there, there's all sorts of great things about that. So anybody else want to mention anything for this?
I know Brad said that he was going to try and take a couple minutes when we're all wrapped up and everything as well.
Okay.
Just very quickly.
That's fine. Okay. Next we have Pam to talk about the website.
Yeah. Let me cover a couple of things real quick too. So specifics on the house team. So one, again, we really do feel like we've accomplished something really amazing here. And it's because of the people that are in this community. But what we've done so far is a lot of kind of initial searches, initial findings, some really incredible things. But unless that goes forward, unless we find a way to create a legacy for that, it could all be for naught. Right? But some of the information that was found, some of the data models that were created, some of the data sets that were found, the processes to get to these things, the training needs, all of this stuff can go forward to help additional people's careers, to help researchers in the future, can help governments, other organizations, not only here in Utah, but around the country and hopefully eventually around the world. And the house team is actually came together for this idea. Matt Davies and Pam and I talked quite a bit about data lakes and this concept of getting as much information out there and making it available for as many people as possible. One of the powers of big data is not just the size of the data that you can collect and everything, but the fact that you are doing this massively parallel processing where you have tons of computers all working together to accomplish something bigger than they could do on their own. That's really what this community has done. But we can continue and expand that out and have more and more communities and more individuals, researchers, and others take this information and move it forward. So hopefully universities that we're pushing towards, governments, many others will pick up our flag and continue it on. To make that a little bit easier though, originally it was like, okay, let's create this data lake. We'll get a bunch of servers and we'll stick the data. It didn't really work that way, right? We'll just flood civic data with as much information as we possibly can get. And again, that's probably not the best way to be able to create this huge, massive information, or at least to be able to access it. Right? So we had Pam go in and create a site, and she created a beautiful site that we'll talk about here in a little bit. We also had Jonathan go in and create, a lot of indexes and other information so that we can get to that data quickly. And he'll go into that a little bit more and show how cool it is that we can actually find this information and you're not sorting through the internet, right? Let alone the CDC once you get there and trying to figure out how to get to it. And I mean, many of you know exactly how painful that can be, right? And then we've also, and this is for Craig's piece, and I still don't see it here, but we've also created a space where we can collect new data sets from social media. I guess I'll let him talk about it if he makes it here. If not, then we'll cover it real quickly, but also really cool. And then when we wrap up here, we may take a quick minute and kind of do a quick recap on some of the teams, although more of that will hopefully happen at the conference next week.
So Pam, you want to talk about the site?
Okay. I'm going to sit.
I'm going to sit and drive.
All right.
Well, I was going to
Can
say,
I? Oh, or did
make
you not
sure
want to
that
do
we
that?
Back to the right one.
let's see here. There we go. But now I got to make sure it's shared because it's not shared right now. So 1 second. Good old Google. There we go. Now it is. There you go.
Okay. So basically, we wanted to have a site that would pull together everything that we've done so that things wouldn't get lost. And we had wanted to be able to include, for historical reference, the details of the competition sponsors, the goal, the rules, all of that, and the dates. And then we also wanted to be able to put pages on here for each of the teams that presented. So each of the teams actually will have a site here, a page. And so I'm just going to go in really quick. Well, actually, I'm going to go into the house team since, it's house team presentation. And there we go. You will have the presentation. So the presentation that you're seeing right now will be up here. I'll also include a link then to this actual presentation on Google Plus here when it's available. Then we've got the members of the team and what our goals were. You can see here that we were conducting, I mentioned the sentiment analysis, data lake, all that kind of stuff, and the competition deliverables. So all of these will link through to the various deliverables that we have. So they're never lost. They can always be found. Also, a brief recap of what Pat covered earlier with how successful were we. Here are our measurable, yes, measurable, our successes, measurable successes. And then we've got also right here some venture teams that are starting to come together and start to talk about, now that we've done all of this, how can we use it to actually move forward into that third stage. Up here, we've got abstracts that were produced and stuck on the Open Civic site. These came from citizen sentiment. So people actually used a form to go in and put down the things that they were concerned about with air quality and all of that. And then there was a spreadsheet that was passed around at first. Then here's the Open Salt Lake site. I'm gonna go down here a little bit further. Okay, Open Salt Lake site. So this will link through to the actual abstracts on the Open Civic site. I'm just gonna go there real
And that
quick.
was a public survey that was sent out to lots of people, asking what they felt was important parts of air quality, what they could do about it.
Yeah, so all of that is organized on here, and those abstracts are there as ideas for future data scientists to come in and say, oh, what is the effect of landfills during an inversion episode during the winter? So there's also this form which continues to be here. So we're still collecting data, and this is available to the public. So we're collecting public sentiments. Going back up to, nope, that one, yeah. Okay, so I'm gonna go over to the data sets really quick. The data sets here are the data sets that were noted in the JIRA repository for the competition, data sets that are stored on the Open Civic site, and data sets that are prepared by the house team. These are the ones that we collected, cleaned, and actually used. Then there are these that were collected. These are all links to the CDC site, so you don't have to dig through all of the layers of the CDC site to get to these various data portals and data sets. And they go down, they include a description of what the data repository is and what the data sets are that are in there. And you can see it's actually quite extensive. So we've got environmental data, we've got quality of life data, health data, mortality statistics, NASA is included, and also the Environmental Protection Agency. So all of those really good, solid data sets. And to tell you the truth, that is, I think, the highlight of the competition as far as pulling the data together and making it available. Now, there's some other goals that are really amazing, and Jonathan has done an amazing index that he's going to talk about next. So, yeah, there you go.
You want to just go to the page? You want to just go to the page?
Yeah.
Okay, is it up here?
It's the top
Yeah.
right tab.
Hey, I got $1 million ideas for you guys. You want to hear
Okay.
it? It's a website for dating. I had a friend come up to me and tell me this. He goes, I got a great idea. So I was like, Match.com. Well, no, it's got a twist. Everybody's got a twist. Okay. Well, he says there's a conference coming up on Monday. You think you could throw it together over the weekend? I've been online. I go to the website generators. I've made a web page. It's pretty easy. Just throw it together over the weekend. It can't be that hard. Okay, there's a database, there's security, there's an API, there's going to be a web page, and the web page is going to go grab the data. You're going to have to format it, and there's this whole process, this whole, all these pieces to this application. You're not going to create Match.com over the weekend. And even if you could, then you have to manage it. You have to maintain it. I mean, who's going to make sure, manage the servers, the uptime, change the API when it needs to change, security, all these things have to be created and managed. So, so Pam gave me this spreadsheet with an index, just all these data sets that we had from the CDC and NOAA and some other places, all this data quality. And what we needed is a web application. So again, we're going to need a place to house the data. We're going to need maybe an API so we can go get it. And we're just a small house team, and we want to pass this off when we're done, not manage it for the next 30 years. So that was the task ahead of me, and I didn't know exactly what to do until I found Fusion Tables, Google Fusion Tables. Anyone played with Google Fusion Tables? Neither did I. It's pretty cool. It's pretty cool. So Google Fusion Tables, they've created a table, a database, and they will take data from different sources, a CSV file or a spreadsheet, and you can load it into their table, and they expose it as a database, and they'll even give you an API. They'll give you JSON, however you pronounce that, back, which is great. You can do a query through a URL, and it'll retrieve the data for you. So I thought, great, and I created this page. This is a very simple page. It's actually just a single HTML page. It doesn't even have to run in a web server. It just sits in, and it calls back. It makes a single call to a page. It's just the Fusion table from Google. It brings the data back. I load it up into some unordered lists and divs, and then I style it. And then I've got a little JavaScript search that will just search the whole page. So if I want to search just for cancer, I can just start typing it, and it will start filtering based on what I type. Or if I'm concerned about birth defects, I've got birth defect in there. Where is it? Come on. There's birth defects. I think I got something funky going on here, but there you go. So we've got all these different things, and then I've got links that I'm creating on the fly. I've got 2 different links for each one of these little cards. One is for civic data, which is where we're loading data permanently, I guess, so that it doesn't disappear on us. And then we've got a link to the original, so if it's still there, we can go out and get it. And we're still populating some of the civic data stuff. But this is a very simple page, very easy, and it just goes and grabs the data, and I can pass it off, and I won't have to worry about it afterwards.
Yeah, what are those different sections? Because I saw that there are a few different air quality and.
Yeah, I'll show you. I'll just scroll through some of them here. We've got air quality, we've got asthma, birth defects, cancer. There's several different kinds of cancer, childhood cancers, climate change, community design, community water, developmental disabilities, environment, and I've filtered some of this out, if you noticed. Environmental prediction, health behaviors, health statistics, and then heart attack. Oh, hold on just a second. I think I'll remove this filter. All right, I'm just going to go back down near the end. Okay, health behaviors, health statistics, heart attack, homes, hospital emergency department, hospital treat and admit inpatient, hospital treat and release, which is interesting, mortality statistics, population characteristics, and some of these, have, hospitalization for asthma. There's a section for asthma, but if you do a search, you can find both. Reproductive and birth outcomes, and we're at the bottom. So this was basically my just first crack at categorization. We've got a category and a subcategory and then a title. And we're going from there to have descriptions. I mean, this can be extended. It's a pretty basic thing, so really anybody could jump in here. It's an HTML page. Just change how it's looping through, add another level, and have fun with it. Just to show you real briefly, if somebody wants to edit some of this data, you can do it directly in Fusion Tables. So this is Fusion Tables. This is what it looks like. This is just a raw table, and you can get in here, and if you have rights, well, you're not signed in, but if you are signed in and you have been given permission through Google Permissions, it's just standard file sharing through Google Drive, then you can get in here and change any of this data, add new rows, whatever you want. So it's very simple. I'm hands off. Everyone, we could have a dozen people, hundreds of people working on this if we wanted to, and we wouldn't have to manage any of it. So any questions on any of this?
How did you do your categorization?
Pam gave me some of the categorization, and I went through and I changed some of it. It could be better categorized, I think. But
that's kind of basically how it's categorized on the CBC site. So when we went in and I was pinning down these sets, I was actually on the spreadsheet keeping track of, okay, this is where I've got, and this is the number that was generated when I pulled down the set. So this is the set name. And then I put the set in the folder and note the number on the spreadsheet that I gave him. And then he just went ahead and put this together. Yeah.
And as we go forward, we might find that we need, a third level of categorization or maybe a tagging system or something. But the framework is all here to make it fairly easy for whoever the next person is, whether it be me or someone else, to come in and take the reins and take it to the next level. So.
Thanks, man. So you remember when I kept saying all summer long that we're collecting data sets and everything else? Well, here's what they all ended up. So this is a lot nicer way to see it than what we had to Yeah, Jira and everything else. So Craig, you want to come up and just go to the page and you can talk about what you've done on the sentiment analysis. And Elasticsearch, so while you're doing that. But yeah, that index is just awesome to use now. It's so much easier. They're all right there on the Open Civic site, to link off to them. The original file is there. It's really simple, really helpful.
By the way, if it's not uploaded to Civic data yet, it'll go there and not find it. So it's there, so when we do get it there,
I do put it up there. It'll
be live.
All right, so talk about yours, Greg.
So I'll face the crowd for a couple of minutes my voice doesn't carry that well, so I'll speak at you. So this is kind of one of the projects here put together. The idea was to try to gauge what people are saying about air quality, more particularly in Utah. This isn't confined to Utah. It goes out quite a bit farther. Especially it's probably good timing with our notably bad air quality season coming up here in the next few months, to try to see what are people experiencing, what are they affecting, how are they affected, what are they saying, to try to get some kind of a feedback. So this is built on top of Elasticsearch, and it uses another application called Logstash to pull in tweets. That's kind of the input stream. So a real popular stack in the Elasticsearch arena is called ELK. For Elasticsearch, Logstash is an input method in Kibana, which is a really easy to use front end. We're not using Kibana for this, but we did the front end custom. Speaking of sentiment, about 10 minutes before I left, I got sentiment up. I don't think it's actually very accurate, but anyway, it's at least something up there. So it gives you some of the stuff up here, location, and actually start taking the data I got up here. Some filtering abilities, actually courtesy of some Pam's really good suggestions to try to make the tool a little bit more usable. You can search for tweets, you can search certain users. It'll give you kind of a relative time of how recently these tweets were made. And it has kind of a similarity metric that it does. It's not super accurate at the moment, but if you find a tweet that's interesting, if you click similar and try to find other tweets that are as close to possible as that. And it tends to try and put all the most recent information towards the top of the stack. Since that's sort of the most, the most recent. What people are, it's a current tool. It's what people are talking about right now, interested now. But of course, you could change the time frames. You can go back different periods and see. This is Alan. He's a friend of mine. He's a student up at the University of Utah. He actually did quite a bit of work on this, especially the front end. He did most of the front end work, the mapping work, and then also did some Elasticsearch work as far as being able to search and refine by location. So one of the goals of the competition in general is to try to expand the community, try to get more people involved. And so my way was to kind of work with Alan here as a student to try to get him more acclimated. And he tells me a lot of stories of people that he runs into on campus, professors and other students. They're like, hey, we want to do big data stuff too, or we're working on this thing, or we're looking at that thing. As a matter of fact, today he was talking about Apache Spark, because I haven't talked to him about it before when I first saw him. And so this kind of stuff is kind of, it's growing, it's getting out there, it's again, trying to grow the community and get more people involved here. So just a couple of things real quick here. So if you can filter by location, which kind of tries to take into account a little bit of what people are saying in the area. The mapping works pretty well. The biggest issue is, the sentiment analysis, it does it on the fly, and so it's fairly time consuming. It'll come up in a minute. There's not a lot of tweets that contain location information. So one of the enhancements is actually, so a lot of times people won't put their location, but they'll talk about a location in the tweet itself, like these right here, loved Utah. So one of the enhancements is to be able to do feature detection on the tweet and try to pull out location information, and then we can make that mappable. It's not perfect, but because if someone in California says, hey, I want to visit Utah, we'll map that as Utah if there's no other mapping information, but it's related to Utah, but they're not tweeting from that location, they're tweeting about that location. So if we click on the map here, the map stuff is really cool. This is done by OpenStreetMap down here, and Leaflet is kind of the library that we're using. It's really quite slick. So if you click on any of these dots, it will kind of pick up the locations for you. Map's coming up. Works a lot faster with a landline. And it kind of works the other way too. If you click on one of these links here, it'll show you the location. So looks like they're tweeted from a golf resort there. Not sure if that's exactly accurate, but apparently is. Oh, it says playing with Bobby on another beautiful day. So it looks like they're out golfing. The chart up here at the top tries to give an indication as to when people are tweeting. Actually, I guess it's not sensitive to this click yet. I need to tie that in with a map a little bit there, but any of the other stuff it does. So it's kind of fun. I personally am not a huge social media person, but it's kind of fun to search around a little bit and see what people are saying. We found out about an air quality dance that came up on a tweet that I had no idea about. I didn't know you could do dances on air quality.
Only on good days.
That will be planned for next year.
It'll be a formal dance, the air quality dance. So I'm not big into interpretive dance. But we found out something that that we didn't really know about that somebody else was doing. So it's fun.
Thanks, sir.
Great.
So,
Yeah.
Oh, question, sorry.
Yes.
I just had a question. What terms are you searching for behind the scenes then before you? Because if you just click
Okay,
go on the
good
blank,
question. So if you just come up and there's no terms, it pulls up a list of the most recent tweets that are in the index. It orders them by recency. And so if you like, I filtered just on Utah, so it does the same thing except you uses Utah as a placeholder. So it's the most recent tweets that have some relationship to Utah.
so it could be any kind of tweet, not just air quality.
So this is limited to a set of terms, including things like air quality, bad air, bad day, good day, beautiful day. A lot of people tweet about beautiful day, and it's kind of messy because you could say all kinds of things about beautiful day that aren't related to air quality. And so this is where we get into putting in smarter tools into this. Being able to use some kind of a Bayesian filter to say, yes, this is something that I'm interested in. This is actually not something that I'm interested in. So like inversion is a common term, but it also has applications in finance and money and stuff. It's like, well, we don't care about those inversions. We care about other kinds of inversions. So that's maybe phase 2 to get into better analysis of that.
And our goal was a wide range. In other words, beautiful day, things like that. We kind of gave the guidance to Craig that, yeah, throw in ranging terms out there. We weren't looking for these specific things. We wanted
But if it sorts air quality, it will focus down. Yeah, it's sort of the big data mantra, right? Pull in everything that you can, and then filter it out. So the sentiment is sorry. Go ahead.
Well, I was going to say, collective, it's 674,000 now. Tweets.
Yeah.
And that's
So by the
been-
time we get to the competition, we should be about 1 million.
and this started 3 weeks ago, 4 weeks ago. Is that about right?
About a month ago. Yeah, that's about right. So, like the sentiment, one of the things we can do is give you a button, or some kind of a selection to allow people to say, to give their input. This says, it's a positive sentiment, I disagree, and put that back in. I threw this up in about a few hours today. So it's really, the paint's really fresh already. The other thing as well, especially as far as locations, because there can be tweets that are from cities inside of Utah that aren't, that tweets not correlated with Utah. And so the idea is, if you select Utah from the drop down behind the scenes, we can actually expand the search to include all the cities within Utah to be able to, or give you the selection. I just want anything that mentions Utah, or want anything that mentions Utah or cities within Utah, right? And there's a library that we have that can do that for us. You got to wind it in. So it's kind of neat. Sorry, does that work?
Mhm.
Yeah.
Yeah, and the colors are the sentiment, is that what kind of where you?
Yeah. So it's supposed to be gray is neutral, green is positive, and black is or black.
It is red. You're working a lot on it.
Yeah, apparently, yeah, red, sorry, red is negative. So apparently formaldehyde is a negative term. I guess it would be in terms of air quality. So this is, so I found a blog that talked about a Stanford NLP, natural language processing library. He had an example I was able to put up in a couple of hours. But I think it's more geared to larger bodies of texts. Tweets are always hard because they're extremely messy, right? There's all kinds of, there's not too much in these, but you've got all these shout outs and stuff and all these other terms. People, a lot of times you have links, URLs, and things like that. So the next step actually is going to be to try to strip all of that stuff out. And if there's only a handful of terms in there, it's hard to gauge the sentiment. But if there's enough terms, then you can give it to the engine and have it try to gauge the sentiment. Probably not. I don't know. There'll be
Okay, great.
something.
There's,
What was the question?
Beautiful day for big data apparently doesn't like that at all.
yeah, that's funny.
So there's a talks of phrases with the words near each other that match.
It's not doing that at the moment, spam queries, but that's one of the things.
You're right. A lot of negative things about big data.
It says traffic, so maybe traffic is better. So I just threw this up. I don't have a lot of insight into it. But
Well, this one must have just got spammed, because looking at this before, you could actually find stuff about the big data competition we just put on Twitter. But now I actually think this is probably an automated bot that's tweeted out a million.
yeah, so that's So
That's the other problem with Twitter.
Ad auto there.
Yeah, so so there's different strategies. Like these are all retweets, and so we could filter retweets out. We could also filter out different bots or whatever on input or on the index. So Twitter's a pretty messy world. It's interesting, but it's very, very messy. Anything else?
One other cool thing that we had Dr. Arden Plope suggest was once you have this information, somebody could go in and start searching what people do to get out of the bad air as well. So, or other things that they do that are related to air quality.
Bad day, not going outside.
Okay, thanks, Rick.
Thank you.
Let's switch back over to the Prezi. And now I gotta switch on here. Where is it?
It's in there somewhere.
It's the problem with so many things open.
Yes.
Oh, here it is. There we go. Okay, so let's move forward a little bit. So we talked about each one of these. I'm not going to go over them again. All right. And then we'll let Nick talk about some of the future projects and where the house team is going with all this and some of the places where we're working. So.
Yeah, so right from the beginning, we wanted to make sure that the community itself grew and that well into the future, we would have a lot of success and this would benefit everybody, right? So we made it absolutely sure that the code would be open source from all the teams. So the data that we use, the code that everybody has created, all of that stuff can be built on for years to come. Right? We wanted to make sure that others who really know this space can also take the information that's out there and try to build on it as well. So we've been working with the University of Utah. We've talked to Utah State University and some other groups as well to see if maybe they'll start putting this into capstone projects for their undergrads or for graduate students, or just take it into their own research facilities. We had some pretty strong interest there. The University of Utah is talking about taking this to all capstone projects for their undergrads. So hopefully that'll happen as time goes on. Also, again, it's all open for global research. It doesn't matter who you are, where you're at. Everything that we talked about today, this is all stuff that can be used all around the world. That could potentially be very, very powerful, right? If you guys can help us spread the word on social media, it'll go pretty quickly. We need it to become kind of viral because some of the teams have actually created some things that could help us solve the air quality problem. We could actually clean the air. If that's the case, we could save thousands of lives. We could get rid of tons of diseases. Right? We'll take Dave Sewell's 380 lives or whatever it was, and we'll just make it huge. So anyway, we're also going to take this as a template for other states. A lot of that front page that you see, we'll take out to other states. We'll have others try to push that forward so that this can be projects that they use in their areas, whether it's with their big data groups or with research groups, etc. And then all of this ties back to the state has a bill called SB 70 that requires them to have all of their data open. It's the Open Data Initiative. And so a lot of what we've done behind the scenes is we've taken a ton of state data from DOT and DOH and UTA and a whole bunch of other places. And we've made that so it's all now searchable, findable. It's data that the different departments can use. This helps them to create this going forward for what they want to do as a state as well. And then hopefully we'll have additional competitions on this particular piece, but no matter what, we'll have additional competitions for big data and big data.
One thing I'll add to that for the SB 70, even if we didn't actually accomplish all of the data sets being clean and all of that for the state, we still broke down those barriers as well. I mean, the state basically invited myself and us in the House team to come into their data sets and pull them out. And that's a huge step to move into those things, to get them ready to know what can be handed over and what cannot. So even that whole process helped the state move forward with that.
Just as many companies have their data very, very siloed, the state has their data very siloed. Even within certain departments, the data is siloed. They have no idea how to get access to that data, to read that data. This will help that. They're going to continue to move forward with that, and they're doing some really incredible things. In the long run, it makes everything more powerful and more valuable, because you can see how the transportation data relates to the air data, relates to the health data, relates to education data, relates to all of these pieces once you can put it all together.
You know, the other future thing we didn't mention on here is the next big data mixer, which we're already planning. We're already talking about in November. You know, we don't have dates or anything, just give us some time. But there will be another one. And the whole goal there too is to talk about what was done in the competition, to keep driving that forward, of the air quality, of the big data community, and everything else, because we keep putting that into people's heads and we tell them, here's what you can do, here's all this data, go and do it with that. And so it helps to improve that.
Well, like Pam was talking about, a lot of this can be turned into venture type things, or other users groups, or there are teams that can turn this into financial gain for their particular groups. And again, there's obviously all the health things that we can fix, etc.
Okay. So last thing that we have is basically we just come right back to the goals that we had to start with. You know, we feel that we were very successful for the summer. From all the feedback from a lot of different people, we did a lot of different data pieces and just bringing everything together. You know, I think overall it was a very successful summer. In my opinion. I hope everybody else agrees.
And help us alter it as time goes on. We
Yeah.
want this to
Keep
be
moving
successful
forward.
for everything.
Yeah, we want to keep pushing this forward, not only for the teams themselves, but for the data itself as well. I mean, we want the data to take a life of its own and move forward. We'd love to see professors from the U or other people use that data and say, I can at least let them go play with this data set, this 1.6 terabytes of data hanging around that they can go and play with. So, okay, any other questions for us? No? Okay, that's it from us. I'll get the next presentation ready. So anybody online, I'm just going to switch around.
So how many people here learned something about air quality this summer? Show of hands. Like, I didn't know what a PM 2.5 was. Right? What the heck is that? You don't know that. And how many people learned something about big data that you didn't know before this competition? I think all of us did, right? So I know that my experience, I've learned a ton on what we did. And there was a lot of people that came together to make it happen. But two in particular, they really did a lot, right? Nick and Pat helped out a lot. So on behalf of the rest of us here, let's give them a big thank you for that. Now, one thing I learned about Pat, joining the group, is he's the and he knows how to run the Google stuff. But Pat, you also had a shirt that I want you to kind of explain. One of the first times I met him, he had this T-shirt that said, "There's no place like 127,001." Can you explain what that is?
There's no place like home. That is your local IP address on your network card.
Okay.
So it says there is no place like home.
There's no place like home. Okay.
There's no place
So we all know that we need to stay up to date with the latest technology. So we got this one from Pat from the community here. What is that all about? You know, that's.
I don't know.
Okay. No place like ::1. This is IPv6.
Ah.
So that one's IPv4. So on behalf of the community.
Thank you.
All right, and Nick, we got something for you too here. Since Nick is always in search of big data. I got this in front of Nick. So here,
Awesome.
Thank you. Thank you both. All right, so I appreciate that. And another great reason to just mention right now, Big Mountain Data next week. We have 500 shirts coming. Everyone's going to get one, and I have to say these are the funniest slogans you are ever going to see. They're related to big data. No, I will not tell you what they are. You have to show up. I will not be favoritism on certain slogans because they'll all be different. I will expect you to talk to the person next to you and trade. Okay, so, but yeah, you're really gonna love them. A lot of great things like that. We came up with them, and I think everybody's gonna enjoy them. So Lonnie, why don't you go ahead and come up. This should be set up for you. The broadcast will switch over. I'll let you do your introductions about yourself and stuff. Let's see if we've got this. Let me make sure this is. Yeah, there we go. So just back and forth, and you should be ready to go.
Okay.
Okay.
So my name is Lonny Northrup, and I am a healthcare big data solution architect for a company in Virginia. Okay. We're a big company with about 100,000 employees worldwide, but most people in Utah have never heard of us. So Computer Science Corporation, CSC. So I'm part of a big data group. We've got, just over a year ago, we started with about 700 people, and now we're up to about 1,200 people in our group. We've made a couple of acquisitions of some small companies. So we're a big organization, but we've done data for 50 years. So the latest, what's big data? You know, back when I was almost 30 years ago, I was doing work with artificial intelligence. And we thought, you know, this is great stuff, but the problem is that there weren't enough computers, there wasn't enough storage. You know, we came up with these amazing algorithms that you can never run because it cost too much and took too much storage. So now that's changed. Particularly when you can go out to Amazon and, hey, I need 1,000 CPUs for 2 weeks and and maybe I want to have 500 terabytes of data. You know, you couldn't do stuff like that in the past. And so we're really in a little soundbite from an article I read a few weeks ago was when the unaffordable becomes affordable, the impossible becomes possible. And we're kind of heading into that. But, you know, working with companies that pay money for things and try and, you know, report earnings to Wall Street and stuff, they're a lot interested in what does this do money-wise, okay? So in the last 3 years, I've probably interviewed well over 100 companies. Maybe not quite 200, but well over 100 companies that are big data companies. You know, and so it's like figuring out so basically if your software has data, it's now a big data company. So trying to kind of sort through that is quite interesting. So one of the questions everyone always asks, what is big data? So trying to figure out what you can do with big data. So what does big data do? So we face this endless conundrum of coming in as like, I've got big data, I need to do something. It's like, all right, what do you want to do with it? Big data. And so anyway, this comic is great for that because it's kind of this chicken and the egg. You know, what do you do with it? So in terms of this is kind of the the 3 V's that most people talk about is volume, which is the big deal, variety, and velocity, and then this other dimension, veracity, is really the quality of the data. I mean, if you, just like, you know, we were looking at some of these tweets, and if the data's not aligned, you've got some inversion talking about financial terms and some inversions talking about environmental terms. If you don't get the data straight, you can't make sense out of it. So these are all, but ultimately in healthcare. So I spend all of my time in big data for healthcare. And data for healthcare before big data for healthcare, is to, in healthcare, improve the care reduce the cost. And so if there's no value created, we don't see much point in doing big data. So, so here's, there's a lot of hype. So like 95% of CEOs in healthcare are pursuing big data. And one of my coworkers went to a Gartner session for CIOs on big data. And he said he met two kinds of CIOs. One, the CIO that was already doing Hadoop, and the other kind of CIOs were the CIOs that were going to do Hadoop. And he asked all of them what it was they were doing with it. Could not get, not from a single one of them, could tell them what the business is. So what ends up happening right now is big IT departments are buying Hadoop, buying Netezza, buying SAP HANA, buying Exadata, but they're not talking to the business to see what the business wants to do with it. So as a result, about 90 to 95% of big data projects today never produce a business outcome because they're just exploratory experiments, and a lot of times they're ill-formed as it relates to trying to accomplish something. So, but there actually are real things being accomplished with big data in healthcare. So here's a few examples of reducing readmission rates, reducing the cost of high-cost patients, predicting who the next high-cost patients are going to be. So in healthcare, over half of the healthcare cost is generated, and this is worldwide, is generated by 5% of patients, okay? And that group is turning over at about 80% a year. So predicting who's going to be high cost and intervening to prevent them becoming high cost is really a valuable thing to go do. Real-time monitoring of infectious conditions, either sepsis or neonatal sepsis. So the number one cost in healthcare is labor. So reducing attrition. So this one is taking one for nurses, but first year attrition and new hires in healthcare is about 40% nationwide. So reducing that is significant. Just straight, getting paid for things you've already done. There are some advanced things. So one of the technologies that we're doing some investigation into is actually similar to the IBM Watson technology. So IBM Watson does something they call cognitive learning. Well, the new IBM Watson does everything that touches data at IBM. So IBM rebranded everything data to Watson. Okay. So now if you have a DB2 database, Watson. Everything is
Watson 1.0.
But the original Watson that competed on Jeopardy and won is using something called cognitive learning. And so we're working with another solution that actually took echocardiogram data to perform diagnosis and running it through. It's kind of a combination. It uses both structured and unstructured data together and graph technology to determine relationships. Created an algorithm that was 90% accurate with 1% false positives, whereas the best algorithm prior to that was in the low 70s with double-digit false positives. And that 70% algorithm had the advantage of two of the leading echocardiogram doctors in the world helping to tune the algorithm. Okay, so there are some new things happening. Here's one around personalized medicine. At CSC, we've got a group over in Germany doing work with leukemia patients, and they treat them with something called cord blood. And so the same way we would get, A, B, O match, if they can match the genetic characteristics of the blood for the treatment to the genetic characteristics of the patient, they actually get a dramatically improved treatment. So what that solution did was to take genetic markers from patients and then compare it to a globally published data bank of cord blood. And then it would find the ones that were best matched, and then they would transport the blood from wherever it was in the world to those patients. So there's some work around suicide prevention. There's also some things that just speed up analytic insight. And so we're not going to have a ton of time. So what we've done is to try and translate all of this big data hand waving into something that's pragmatic. Okay, so what we're pursuing is, one, first, it's like we're already doing lots of stuff, so how do we do something better? Okay, so using data sources that we're not currently using analytic tools that we're not currently using to get insights that either you couldn't do before, or, you know, like the artificial intelligence, it wasn't cost effective to do before, leading to better outcomes, reduced costs, and also improve patient experience. So, so what big data tools are best? Okay, so this is done by 451 Research. So just looking at big data databases, or just databases, period. If you look on here, you'll find Elasticsearch, and you'll find, you know, Cloudera Hadoop, and Hortonworks Hadoop, and DB2, and MySQL, and on and on and on. So the challenge is, what do you even try to use? You know, and it makes it even more challenging if you don't know what you're doing with it. Okay, let's throw a dart, and we'll go with Rackspace Cloud Databases. Let's do one of those. So the selection of the tools can be overwhelming, particularly if you're not quite sure what it is you want to go do with it. So there's a movement. There's a guy by the name of Tom Davenport who's now part of IIA. I can't remember. International Institute of Analytics or something. So, but basically, what he's saying is traditional analytics were the relational databases augmented by statistical analysis. So things like R and SAS and SPSS types of solutions. But then big data came along, which started to be more like Hadoop, MongoDB, Cassandra, all these new, you know, Hive, Big, HBase, Spark, all these different things, right? So, and most of the big data where it actually was productive was companies like Google and Amazon and others that started this stuff, was that it was so big and it didn't fit in the relational database, or it wasn't cost effective, so this was the new way. Well, for a period of time, there was a belief that this was going to become a replacement for that. And as it works out, it is not a replacement for it. So what this Tom Davenport suggested, and this has been around for a year or two, was that big data actually augments traditional analytics, but you focus it on a specific business need. Okay, so now, like that echocardiogram stuff, or like hospital readmissions, or like detecting infections in real time, these are the kinds of things that you focus it on. And if the traditional analytics could already do it well, then maybe this doesn't happen. But maybe it does. So one example was a company called Seton Health. And they had a hospital readmissions algorithm based on structured data. And they did some work with IBM and their content analytics. So doing NLP type of processing to go find structured information out of the unstructured data, medications, treatments, diagnosis of conditions. But in NLP, it's a little more complicated because it's like, okay, I'm talking to my doctor and I'm telling him about my mother and my brother-in-law, or my brother-in-law should in fact do that. And so family history that might influence things. And I'm saying, yeah, my dad had a heart attack, and yeah, my mom doesn't take anything for allergies. And, so what you have to come up with is something called negation and attribution, or just two simple aspects of NLP that some of what you're dealing with, just trying to do that on your own from scratch is very complicated. So in healthcare, it's even more complicated because you get into all these ontologies and taxonomies and things. So Seton came up, so they had like about 111 or 113 dimensions. They found 18 other dimensions in the unstructured data. And some of those they found to be more predictive than any of the structured elements. So, but here's the frustrating part. So they took the structured data and they said, oh, that algorithm is really good. And now we've got this unstructured algorithm, and it's pretty good, but it's not as good as that one, so we're going to throw that one out. and it's like, no, put them together and get a better algorithm, right? So there's still this challenging mentality in the industry right now of wanting, it's an either or thing. And so, but in my opinion, the magic is going to become combining the two, okay? So like, we look at Twitter feeds to get sentiment analysis. So let's go, listen to Twitter and see what's going on with people's health in Utah. Well, guess what? 90% of people are not tweeting about their health in Utah, okay? So instead, what we do is go buy a database from a place called Nielsen. So there's this database called Nielsen Prism. And now I'm kind of the guy that likes to share information. Chuck, Chuck doesn't like to share information. So we're kind of like the opposite ends of the spectrum. Okay, so I like to share information with the thought that everyone's really good at trying to do good things. So let's make it available, right? So I'll tell you, that database scares me. Okay, so it's like this database will say, what cars do you own in this household? What movies do you watch? What music do you listen to? Where do you shop? I mean, it is a little bit scary. So, but however, it's dramatically more helpful than Twitter feeds, okay? So you really have to get at where can you get the best data to address the questions that you're trying to cover. And one of the things, I won't go back to, but when we're talking about additional data sources, one common area of additional data in healthcare that isn't really used is you've got all this data streaming from devices in the intensive care unit. And because it's so voluminous, the standard practice is sample the data and then stuff it in a relational database. But the trouble is the sampling is here, here, and here, and then you've got this going on in between the data points, okay? And so the doctor comes back and says, okay, that patient had a near call or that patient died. We want to go back and see what was happening. Well, some of these healthcare companies will retain that data for maybe days, maybe longer, but then it just gets flushed after the sample. So now, if you can keep all the data, now you can, so we did a little conference call with a company down in Atlanta, Children's Healthcare of Atlanta. So they started storing all this data, and they were taking it out of newborn ICU. And but the monitors, you got one over here, one over here, one over here. Well, they took all the data, dropped it into Hadoop, and then they just kept letting it pour in and pour in. And then they aligned the data with the medical record. So they went out into the relational database and they pulled all the demographic data in and they aligned it so they knew which patients and what kind of history they were working with. And then they fed it out through ClickView to do a visualization that actually mirrors what was happening on those monitors that went on and off the monitor. And now they can go back with those 3 devices in sync to one another and scroll back to any point in time forward. And what they found is they can then look at, okay, when did we connect up an IV? When did the baby go through some type of diagnostic procedure and what did that do to the vital signs? Okay, so there's getting to be these new things it can do now that you couldn't do before because of the cost. So, so it's combining public data, private data, structured data, unstructured data. The magic is being able to not only do the things we could already do, but bring in the stuff that we couldn't do before. And so for an organization doing analytics, you got to figure out where you're at before you try something new. So it's, you know, kind of like you don't, Major League Baseball players are a little bit different than high school baseball players. You start in a different place. So, but the movement is from how do you do business intelligence reporting, figure out why things happen. Some of that can be done with statistical analysis, but eventually get into predictive analysis and then prescriptive analysis is what we should do. So this is just something that we use at CSC to just take an inventory of what companies are doing. Do they have NLP capabilities? Are they doing advanced statistical analysis? Do they have a data warehouse or not? You know, what are they doing with search, etc. So this is one, and just for time. Okay. So this is what I alluded to earlier about 5% of the patients accounting for half the cost. Okay, that would be descriptive. It's like, okay, we know that. Well, we should know that. But even some healthcare systems don't even have that data. They can't even tell you who the most expensive patients are. But what if we could figure out who in this is going to become the more expensive patient? Because if someone goes from here to here, their cost of care goes up by 10 times. Okay, so being able to predict who that 80% is and intervene to prevent them from coming over here, huge potential impact on the cost of healthcare. And then that prescriptive piece is then figuring out which of those that are going to be expensive, which ones can you do something about, and which ones can't you do something about. But literally in the US, this use case is about $1 trillion opportunity. Okay, so there are huge opportunities for improving both cost of healthcare and the quality of healthcare. And I'm going to give one example using traditional analytics that has just recently been. So I'm doing some work with Intermountain Healthcare. And Chuck is at Intermountain, and he's the reason I'm here because he got this big data initiative started, and I happened to come along and come help it. But so this year, Intermountain, in the United States, there are massive cost variances for certain procedures. Okay, so if I needed to have a knee replacement, the difference in cost between the highest cost for knee replacements and the lowest cost for knee replacements is like 30 times different. Okay, so and it's this way for most medical procedures. So part of the way we drive cost out is how do you get the high guys down to the low guys? Well, even inside Intermountain, there's variance in all of their hundreds of thousands, millions of patients. So they were doing a surgical cost reduction initiative this year. And basically, just looking at hip and knee replacement surgeries, they're able to take out almost $20 million in cost in this year, just by really focusing on 3 things. One, getting patients that need knee and hip replacement surgeries to the lowest cost, highest quality clinics. 2, they had dozens of suppliers of the parts for the knee and hip replacements. They've now reduced down to a handful rather than dozens. And the third one was every knee and hip replacement surgery, the parts come in a kit, and the kits have options, and you pay for every option. So if you got a kit with a couple options, you're just double paying. If you've got a kit with 8 options, you're paying a lot more. So they reduced not only the suppliers, but the number of options in a lot in a short period of time. So the message I'm trying to send here is that big data is great, but it needs to be guided towards something that produces an outcome, and not just be the science project. And so finding ways to augment the old with the new to achieve something better is really where I think big data is going to succeed beyond what it's done for the totally non-traditional systems that are just using Hadoop type things but aren't relying on relational data. So this is an eye chart, but it's really, so we've been in the interviewing of companies, we've also been interviewing users of big data technologies. This comes from UC Irvine, and I'm showing it because it's published publicly. But basically what they've done is they've created this data lake, okay? And the data lake is where they land all the data, okay? So they still have the relational database, in their case in SQL Server, but they've taken their incoming data marks and they've moved it out of the database and into the lake, okay? Because then you can, so today if you have a data warehouse, 70% of your cost is in the ETL. How do you get the data out of here and into here and aligned to this thing called a canonical data model? And it has very expensive data modelers and data architects. And so you end up having to say, if I wanted to create a report out here, then I come back and I've got a data cube that denormalizes the data so that I can feed the report. And then the cube got created from third normal form tables in the database. And then before it got to there, we had to go to ETL and figure out what tables we're going to create and what data elements we're going to put into it. And then we decided, oh, I need another data element. Okay, let me go back over here. And so it becomes very challenging. So the point of the data lake is you basically try and do a one-for-one, mirror the data in. So now using these advanced tools, so like here, using Swoop, and you described using Kafka and stuff for streaming data. There's a lot of ways to move the data in, and then we can store it in Parquet, or we can store. So you got to decide how you're going to store the data, and then so there's still a lot of work to be done. But what these guys at UC Irvine did, they just drop as much as they can one-for-one, but they still register the data when it comes in. So using HCatalog and Hive, so that they've got the metadata around the data so they understand the source of the data. And then first thing they do is just run Solar search over the entire thing. So now they've got a way to go navigate through the data to try and figure out what to go do with it. And then they move into the analytics of doing statistical stuff like R and Weka, doing machine learning with Mahout, MapReduce, SQL on Hadoop, like the Impala and test type stuff. And then they also are doing document databases with Mongo and graph database with Neo4j. So but they have use cases that drive this. And so these yellow things are cohort discovery, readmission predictions, home health monitoring, all these real-time tracking of devices so that they can figure out what the utilization of equipment is and where they can get rid of equipment and keep equipment. So by aligning it to these use cases, and then it has to get delivered out in an application form, and the algorithms need to be applied so that you can alert someone, hey, within the next 72 hours, this person is going to go into septic shock. And if we can predict that 3 days before it happens, we can actually prevent it from happening. If we only find out a couple hours before, too late, lots of money, lots of risk of them dying, et cetera, et cetera. So the whole point of this, so this is, in my experience, the best I've seen so far. And they've been using Hadoop for years. But they've moved beyond. I refer to HDFS as cheap storage. MapReduce is not the best way in the world to query your data necessarily, but it. I mean, at CSC we've got some projects we're doing for the intelligence communities. One of the projects has 120 MapReduce programmers on it. The other one has 180 MapReduce programmers on it. My suggestion is you could probably get a lot just using a solo search on top of it to start with, right? So it's like, MapReduce isn't the magical way to free the data, in my opinion. But HDFS is a great way to store it. And so that you can do schema on read rather than schema on write, and you take away a big part of that 70% cost in ETL and data modeling, et cetera. So anyway, I just wanted to, I feel like I've been a freeloader on this since I connected up with you guys in the middle of the summer. I'm not sure how useful this would be, but I wanted to share a perspective a little bit different than the very technical perspective that we tend to get in on some of the tools and the application of the tools. But just want to send the main message of don't lose sight to what the business outcome is and what the business value is when you're applying the tools to go solve problems. And any questions?
So do you see in the healthcare industry them still driving towards, say, a traditional data warehouse instead of moving to something non-traditional? Some of the things that you showed up there, some of the other things. Do you still see people driving for that same traditional warehouse that they always have?
Yeah, Chuck, go ahead.
I was at the data warehouse conference for healthcare last week in Maine.
Yeah.
There are so many healthcare organizations that don't even have a data warehouse. They don't even have that. They're struggling to get to the point where they can bring data into an environment where they can integrate and then do analytics and things like that. So,
But do you see those companies saying, that's my first step, that's what I have to get to?
well, in the context that Lonnie's presented here, where we're trying to tell these people, you need to not jump all into big data, and more what you can gain with relational stuff. Because all our data right now is relational anyway, and they're transactional databases.
Right.
So they are trying to get to at least a rudimentary data warehouse. But when I did the presentation last week on big data at this conference, there were lots of people who were very excited about the possibilities.
Yeah, I think the big thing from my perspective is trying to lift the load of all the heavy data modeling and do a more discovery-based approach so that you reduce that. So one of, so CSC's Chief Technology Officer for Big Data actually came out and met with us a month or so ago, and he used to be the CTO for Splunk. And prior to that, he was the Chief Technology Officer for Expedia. So he implemented Hadoop and Cassandra 6 years ago for Expedia and all this. His opinion is that landing all the data is the thing to do. Yeah. And then, but what he recommended is using a next generation tool, and he said like Pentaho or Talon, to get the data here so you can combine this data and this data together natively. And it'll reduce that ETL cost and the complexity, give you a lot more speed and flexibility. So Pentaho is something that we're actively working to learn more about. And it's open source, and so I would highly recommend others take a look at what Pentaho can do for that Analytics 3.0, bringing the structured and the unstructured together in a faster way. Because at some point you still have to apply data quality. If you've got garbage data, you're not going to be able to use it with any high degree of precision. So
But it's good to hear that there's a drive for that, because again, that's where I always see the issue too. I stopped years and years ago starting to put into the cube and the analytics side and the star schema and just working on the Hadoop, and then how do we get the data out after that point? Because you spend so much time and energy in the cube and all of that side of it, you waste a lot of that. You know, the
Yes.
projects can't take 5 years to work. It's got to be working in 6 months.
One of the concepts we've had in interestingly enough, aligns so nicely with the whole data lake philosophy. A lot of people think the data warehouse is cubes, dimensional data marks.
Right.
We don't do cubes and dimensional data marks to integrate, so we bring all the data from the source system to the data warehouse, and then we figure out how to model it down.
Okay, so you go further.
So we started almost with a data lake mentality, but then we chose to have time to more data.
Right.
So
So
how,
it's easy for us to migrate philosophically to this.
Right, but a lot of people didn't even know those tools were there or anything else, and they went straight through. And they're sitting with cubes that took 4.5 years to get to, and you know it's a problem.
So when I say data warehouse, I'm not talking about a dimensional model data warehouse with cubes and all that. I'm talking about our Oracle data lake.
Yeah, big. Okay.
so but along with that, where was I going to go with the? This is like one of the over 50 moments. So, how many of you guys know who Ralph Kimball is?
Of course.
Okay, so Kimball promotes, if you go watch, there's a great video that he did, and it's on the Cloudera website. And he talks about this discovery analytic environment, okay? And so, but what he says is the magic is that you've got the visualization and the BI, and so run that as much as you can. The reason why our CTO promotes Pentaho over this is that Pentaho can go directly to this and take this in.
Yeah.
But you can get pretty close with Tableau and ClickView.
Yeah.
And some other tools. So taking that BI layer against this eliminates a lot of the cost that was involved in the traditional data warehouse and that heavy duty modeling. And so I think that is something we're going to see. So the speed with which you can cycle through getting new applications and new reports out of source data that you drop in, you could query on load when you've got those tools in place. And now you can really help your end users very fast, very fast.
So let's say that you're a greenfield project, or you're, like some of the groups that we met with, that they have no data warehouse. They really don't have, maybe they have one SQL Server platform, but they've got everything else you can possibly imagine from the old worlds, right? Would it make more sense to still build a relational solution for all of your structured data and then have a NoSQL solution for your unstructured data, or would you skip a lot of the relational database?
So the question you just asked was a question we asked of Eddie Saturday, our CTO. And his answer was, first thing he would do, create the link.
Yeah.
And then he would get Pentaho, Talent or something, so that you can move it in, register it, figure out what it is, and it's got the BI piece in it as well. So you can create reports right out of it. Then, as you identify repeatable, more structured data that needs to be, and Ralph Kimball calls it a high performance. So we need fast query with tight coupling, maybe even master data management and other things, very, so like financial data and other things that have to be precision managed. Then you move those things into the high performance. It can either be traditional Oracle, DB2, MySQL, or it could be where most things are going now for more scale is the columnar databases like HP Vertica, Cassandra, and other types of columnar databases that can still do SQL, but they can do some, if you've got massive table joining stuff, you can do things that are 100, even 1,000 times faster. And it scales to dramatically more users. So those kind of columnar databases, so he would say the data lake, Pentaho type tool, and then a columnar data store. So that would be his answer for someone starting from scratch, who still has all this and anything else they can think of to put in. Good. Well, appreciate the time. And hopefully that was useful.
Okay, for anybody else left on the call, I think that's all we had for the evening, right?
Yeah.
Oh, my desktop is being shared again. Why is that? Okay, I'm going to stop that on the